So now we are going to talk about areas of different shapes. We are going to start slow. We are going to start about areas of triangles and rectangles. And you can think of these as the building blocks for bigger and more complex figures. So let's talk through these examples, and maybe that will make things clearer. So we are given in the first figure, we are given a rectangle. Uh, how do I know that it's a rectangle? Because all the four angles are right angles here. All the four angles are right angles, and the opposite sides are equal. So this is a rectangle. We want to find the area of this figure. So the area, so I can directly give the formula, and then we can talk about what this area is. So area of a rectangle is equal to the product of its sides, which is length times its breadth. Or equivalently, you can think of it as, so how many small squares of side 1 centimeter by 1 centimeter. Here it is, centimeter is the unit of length. How many small squares of side 1 centimeter by 1 centimeter can fit inside this rectangle? And so my drawing is not very accurate here. So, but that's the question we want to answer. That how many small squares of 1 centimeter by 1 centimeter, because that's conceptually what that is an area. So this thing, imagine this is 1 centimeter divided by times 1 centimeter. So this area, either through my explanation or just by direct formula, length times breadth, is equal to 5 centimeters times 3 centimeters, which is 15 square centimeters. What that means is, given this rectangle of 5 centimeters times 3 centimeter side, we can fit 15 small squares of 1 centimeter times 1 centimeter area. Therefore, the area of this bigger rectangle is 15 square centimeters. So that's the basic problem. That's the crux of the problem that we want to solve. So how many squares of unit area can fit inside the given figure? Let's make or rather, let's go through another example that will make this clearer. So now the question is slightly different. We are given a triangle, not a rectangle, and we want to calculate its area. So we know that the area of a triangle is equal to half times base times height. So the base here is 10 centimeters and height is 4 centimeters. So it becomes half times 10 centimeter times 4 centimeter. So 10 times 4 is 40, divided by 2 is 20. This becomes 20 square centimeter. This formula is slightly different from from the area of a rectangle. It becomes half times breadth times height, because it is a triangle and not a rectangle, but it is in the same flavor. So these are the basic shapes, rectangles and triangles. If we can calculate their areas, then we can calculate areas of more complex shapes, as we are going to do in this third example, which is looks like an irregular shaped figure. Here it is a 5-sided figure, and we want to calculate its area. The sum of the dimensions are given, but we don't know if there is a direct formula that can calculate these areas without much thought. Just like there was area of a rectangle was length times breadth, there is no direct formula for this kind of a shape. So we have to use our understanding of areas of rectangles and triangles to calculate the area of this shape. So note that this actually is a rectangle and a triangle. Actually it is a square, because the sides are all equal. So there is a square here, and there is a triangle, and this figure is composed of a square and a triangle. So we can calculate this area. Area is equal to area of square plus area of triangle, which is 5 times 5. I'm going to drop the units for now. Everything is square centimeters, so I'm going to drop the units. Plus area of the triangle will be half times the base of this triangle. This is 5 centimeter times height given is 3 centimeters. So this is 25 plus 5 times 3 is 15, divided by 2 is 7.5, is equal to 32.5 square centimeter. So that's an important thing to note, that Once you can calculate the areas of basic shapes, you can compose the basic shapes into more complex shapes and calculate their areas. Say for example, this was not a square. Suppose it had been a hexagon, a regular hexagon, and with a given side, let's say whatever, 10 centimeter. Then you can break this regular hexagon into triangles like this. All these triangles are equilateral triangles with equal area here. So you can calculate the area of the hexagon given its side by breaking it down into smaller components whose areas are known. So that's how to approach these kinds of questions.